center of the circle. So we are given the mass. The mass in this case is 5. We are also given the speed. The speed is 7. We are given the radius, which is 3.5. 3.5. So let's analyze this one. This is 5 times 49 divided by 3.5. And if we try to analyze this, we are going to have 5 times 49 all divided by 3.5. We are going to have 70 Newton. That is the first part of it. But the question says, what will be the speed if the force is tripled? If the force is tripled, it means we are going to have 3F, and our F is 70. That is, we are going to have 3 times 70 will now be equal to mv squared over r. And 3 times 70 will give us 3 times 7 is 21, that's 210, will be equal to, then we are looking for speed, and the radius will still be equal to 3.5. 210 will be equal to 5v squared divided by 3.5. So that 5v squared will be equal to 210 times 3.5. V squared will be equal to 210 times 3.5 divided by 5. And from here, you can do it straight away into a mathematical instrument, and you can get the value from there. We have 210 times 3.5. Altogether, we are having 3735 divided by 5. So divided by 5 now, we are having 147, which is v squared. So that our v will be equal to 147 square root. And if you try to get the square root of 147, you give us 12.12 meter per second. So let's consider question number 29. If a wheel 1.2 meter in diameter rotates at 1 revolution per second, calculate the velocity of the wheel. In this case, we are going to take the circumference of the wheel to be equal to 2 pi d, because we are given the diameter of the wheel. We are told it rotates in 1 revolution, which means it has covered 1 circumference of that circular part. That's what it means. So we are told to calculate the velocity, and you know normally velocity is equal to distance over time. In this case, we are going to take our circumference as distance. It's going to be 2 pi d divided by time. And this is going to be 2. The pi is 3.142. And the diameter in the equation is 1.2 divided by the time. But if you look at this, it says per seconds. Per seconds means 1 second. Calculate this one now with our mathematical instrument. We are going to see that's 2 times 3.142 times 1.2. Everything together gives us 7.54 in meter per seconds. In meter per seconds. And that is the answer to that, to question number 29. A body of mass 100 grams moves with a velocity of 10.0 meter per second collides with a wall. If after the collision it moves with a velocity 2.0 meter per second in the opposite direction, calculate the change in momentum. This question is all about momentum. Okay? We are going to calculate the momentum before collision. And momentum is equal to mass times velocity. the mass of the body is 100 grams. It moves with 10 meters per second. Let's convert 100 divided by 1000. Then the velocity at which the body moves, 10. Okay, 0 cancels 0. What we are having left, 10 over 10, which is equal to 1 Newton seconds momentum, or it can be equal to 1 kilogram meter per seconds. What's now the momentum after collision? After collision, we are still going to have mass times velocity, because we are told that if you look at that question, it says after the collision, it moves with a velocity of 2.0 in the opposite direction. Underline the word opposite. We are still going to have the mass times velocity, which is equal to, the mass still remains the same. The mass here is equal to 1 over 10. If you change this to kilogram, then times the velocity is 2, which is equal to 5 Newton seconds, which is also equal to 5 kilogram meter per second squared. Newton second. But they said in opposite direction, then you had a negative sign. In opposite direction. So now the question says calculate the change in momentum. The change in momentum will now be equal to mv minus mu. This is u, this is v. This is going to be, for mv is 1 minus 5, which is going to be 1 plus 5. Everything is equal to 6 Newton seconds, or 6 kilogram meter per second squared. That is the change in momentum. Question 31. A body of mass 6 kilogram moving with a velocity of 25 meters per second due south hits a stationary body of mass 4 kg. If they move together after collision with a velocity due south, find the value of final velocity. Let's look at this. We are going to consider the conservation of linear momentum here, and before collision momentum, before collision, which is equal to mass times velocity, will be equal to the mass of the body here is 6 kg with a velocity of 25. We are going to have 6 times 25. That is before collision. We call it M1 V1, which is equal to 6 times 25. That's before collision. Okay. This body collides with a body that is stationary, a body that is static, is not moving. So in this case, for a stationary body, the initial velocity will be equal to what? 0. Then if you try to multiply the mass with 0, everything will be equal to what? 0. Okay? That means what we are having now is because if you have to write the equation for this body, you are going to have M1 U1 plus M2 U2. The mass of the body for the body that is moving, the mass for the body that is stationary, the initial velocity for the body that is moving, and this U2 for the body that is stationary. So everything will be equal to, by the time they collide together, they will now be moving together on the same direction with the same velocity. Their mass will be coming together, M2. So in this case, we are having 6 times 25 plus 0. Why is it 0? Because once it is stationary, the initial velocity is going to what? 0. And when you multiply it with 0, it's going to give you 0. Then the mass of both. If we are given the mass of the second body, the question says a body of mass 6 kg moving with a velocity of 25 meters per due south hits a stationary body of mass 4 kg. So we are going to have 6 plus 4, then 6 times 25. If we try to check that one out, 6 times 25 will give us 150. 150 plus 0, then 10 feet. V will be equal to 150 divided by 10. And what we are having here is 15 meters per second. Question number 32. The question says a machine gun with a mass of 5 kg fire a 50-gram bullet at speed of 100 meters per second. The recoil speed of the gun is, in this case, we are going to have M1, U1 equal to M2. Let's use V. M1, V1 is equal to M2, V2. The M1 is the mass of the machine gun, the speed of the machine gun, the mass of the bullet, the speed of the bullets. And that's what we call the conservation of linear momentum. So in this case, if you look at the question, they say a machine gun with a mass of 5 kg. This is 5. Fire a 50-gram bullet. This is equal to 50 over 1000 back to kilogram, because we are given in gram, at a speed of 100 meters per second. Let's look at what we are given. A machine gun with a mass of 5 kg. That is the mass of the machine gun. Fire a 50-gram bullet. 50-gram bullet. That is the mass of the bullet. Then a speed of 100 meters per second. We have to calculate the speed of the machine. So we are looking for V1. So this is times. So the mass of the bullet now will be equal to 100. Put 100 in this place. By V1 will be equal to, this is 5 over 100 times 100. 100 cancel 100. We have 5V1 is equal to 5. V1 is equal to 5 over 5. V1 is equal to 1 meter per second. And that is the speed of the machine gun. Question number 33. A simple pendulum 0.6 meter long has a period of 1.5 seconds. What is the period of a similar pendulum 4.4 meter long in the same location? We are posed to this question. The period of a motion for a simple pendulum is directly proportional to the square root of its length. Yes, the period is directly proportional to the square root of its length. If we try to remove this sign of proportionality, we are going to have K. Then try to make K the sign of the formula. We are going to have T over the square root of the length. But in this case, we are trying to compare two different pendulums together. So we are going to have T1, L1, T2, L2. The question, let's go to the question again. A simple pendulum 0.6 meter long has a period of 1.5. Let's take T1, L1 as the first pendulum that has all this value. The value is 0.6 meter long for the length. At 1.5, we are having 1.5 square root of 0.6. The question now says, what will be the period of a similar pendulum with 0.4 meter long. We are looking for period and we are given 0.4. So we are looking for T2, the period for the second